We're saying 30. That includes, by the way, the fastening and everything, right? So not just drop it and then walk away. You can also duplicate that, right? So you can do more than one of those setups per building, right? If you, for instance, started one corner and ran another corner and did this, not likely.
Does it matter the size of the height of the panel? How much you can run
No,
it?
the pick is the same, the lift is the same. Doesn't really matter. They come in sort of different size chunks.
First one, man.
Biggest is 6 foot.
You don't leave me with cookies.
Like a corner, really. So
Oh,
it's like,
right.
you know, about 3.
What's the best piece of equipment to pick it up?
Personally, a crane all day long. A rotating telehandler would be next in line. A straight up telehandler would be kind of less ideal. What happens is so the second you have a telehandler, you can only stab straight. You'll find yourself missing, pulling back, shifting. Anything that's a crane would work. Rotating telehandlers are really cool because
So
they're kind of
one of the
middle.
challenges we have too is that we use a post tension slab, so we got cables, so we'll stress it 3 and 7 days, right? So we're wanting to frame like the day after we pour, typically we're racking forms, but we got cables sticking out still because we haven't been able to stress.
Yeah, you
the
don't
cables
stress
yet.
it because the concrete's not ready.
Right, and so I didn't know, can you set the panels from the inside or no?
Hey, and on that, Yona, you got your handles already for your when you're 3D printing in here, right there and there.
Yeah.
Can you? If I was wondering about setting structures, so you could set them, especially if you had something that would grip the panel and articulate it to really, you know, like if you were using an articulating arm.
Yeah, no, also, typically we wouldn't have the trusses, which makes things a lot easier, right? We're avoiding the straps, touching the trusses and all that. I think generally you're setting from the inside. The thing that you'll have mostly on the outside is you're pulling your string line and you want to keep them in a straight line, right? The outside controls the panel, if you
So
will.
you can set it from the inside?
They are setting them from the inside because this is their fastening schedule, right? Down and up.
Right.
And effectively the handles are from, right? So you're pulling inwards, we clamp it up.
Yeah,
Right.
but with your equipment, you're still outside.
Your equipment will sit outside.
So our slabs are typically 10 feet apart with the cables still, and that's something we would have to kind of figure out. Like we'd have to go do our second stressing, cut the cable, stress it, cut it,
Yep.
and then get in grade it so you can get around because I mean our slabs are 10 feet apart, right?
Yeah, you could, in theory, if you wanted, right? You could choose one side to set. If you had a big enough machine, right?
Yeah, right.
Set it on one side and just pull everything into that side, and that will be your last corner. So you could do it like
We're
that.
40 feet wide typically. Yeah, we go 30 to 40.
Yeah, you're already talking like a 75-ton plus crane to do that, right? So it'll add up pretty quickly.
Yeah.
And you could if it
You
was
look really
important for you.
big out front.
Yeah, me and Kevin did one side with 4 cranes. We did radiuses. They were all not to touch each other, right? Like full sizes. It's actually a habitat project, so it was like COVID relief housing.
Yeah.
But we'll get there. We'll get there for that. But I still think with a long enough boom on a rotating telehandler, as long as you avoid your cables, you would be fine all day long, right? And you could get a 60-foot boom on a rotating. You get a 12-foot jib on it. You'll get like 70 plus out of one of them.
Right.
They're not very heavy. The heaviest one is 1,200.
Okay.
It's actually 150 something. I remember we were weighing them. But like, so you'll get basically that means 200 PLF, right? If you're kind of laying them long for engineering. But really, 1,200 times your distance is your machinery, which is not very much. Right? That's the biggest one. All the rest.
So how
of
many,
it,
how many guys typically on a regular crew to set 40 feet a day?
I would choose 4. Machine operator, 2 handlers, and somebody scheduling all the screws behind them. They don't have to go back again with the same.
When they're done, they're moving their.
You don't touch it again. And then that's another point. You could see that kind of here is once it's all up, everything is inspectable, everything is visible. It's kind of, in some ways, you hear 3D printing. A lot of our work is to demystify it to some extent, right? You're really looking at a steel structure with the panel infill, right, for the most part. But you can see all the wells, you can see all the connections, you can see all the bolts. Like there's nothing here that's, at least from a structural inspection perspective, that's any different. This thing itself is different. It's spanning top to bottom, but he has his own sort of data, right? We know what he can take. By the way, we're also forced a 3-to-1 safety factor. So known materials are 1.5.
Right.
Sort of unknown materials are I tried to work out that we're known, but we're not. So then you have a 3 times safety factor built in. So when our panel right now carries about 80 PSF, right, which is basically 180 miles per hour wind, or 82.5 to be 180. But that in reality we feel closer to 270 something, and that's the weakest panel. The smaller they get, the stronger they get. So for anywhere that's like, you know, usually you're not going to see 82 PSF, you're going to see 100 mile per hour winds, 80, 110. How much is it here, by the way?
125.
125, right?
For, you know, we have a tornado.
So our worst panel has a 3 times safety factor to 180, right? So you're really looking here at a buffer on top of a buffer on top of a buffer.
I mean, you got it.
Because we're a system, right? We're kind of looking for this. There are only few places in the U.S. that can go over 82 and a half. The Keys, not really anywhere else so much, right? So we're trying to get this like, not even 80-20, like a 90-10, right? Because we're not gonna make. We toyed for a while with making unique cues for unique projects, right? So like a thinner panel, a lighter panel. It's very complicated to follow. We have enough SKUs as is. We're at a couple hundred now, so. You sort of get your overachiever every time.
Yeah.
That's just part of it. Another thing, I think Brian probably mentioned this, right? We're a little bit of a startup, a little bit of a construction company, right? Depends who you ask and where they're coming from, right? We're the construction crew, but we dabble. So we always have versions of our product, right? You're looking at the second version.
Yeah.
The first version was kind of a panel and frame, was done in the Palm Springs project, and it was really, I'm right if I go too far. So stop me. So it was.
You can do whatever you want. You already got a speeding ticket today. You go crazy.
Yeah, so it was like our foray into. We've done volumetric ADUs in the past. 2018, sort of that's where Mighty Building started, and volumetric has its benefits, it has its losses, but mainly. You kind of are everything, right? So we're plumbers, we're electricians, and volumetric in and of itself has some challenges. By 2020, we were.
Oh, ADU?
So,
accessory dwelling.
yeah, like a granny flat or backyard home. So in California, they became. There was a state bill in 2017 where basically if you could fit one, you could build one. So it's potentially a millions of unit market. It's really tough to do because every building is a specific permit, specific city, specific client. Nobody's done it yet. We were at the time either the first or the second biggest in California in 2020. But the bigger, I'd like to say, the more successful we got, the less successful it was. Right? We're trying to make a building technology. We started hiring entitlements managers, project managers, client relations. Right? We started looking at something else. But that's a separate story for a different time. Mainly, being sort of a tech company in some ways, right? We're always working on versions. So the first version was a panel and frame. It was limited to one ceiling height, one type of SKU, really one type of building, if you will. You could configure them, but you're getting always the same thing. Plus, it was a very nimble frame, so it was effective in cost, but it wasn't able to stack 2 or 3 stories. The second version, what you guys see here, is actually using that same panel. It takes a long time to sort of develop, certify, and test the panel. But because we changed the way that it's framed, right, it sits outside of a frame, or effectively the superstructure of the building and the panel are 2 separate components, virtually any building could be built with this, right? Another thing that we did is that we said, now that you're outside of the frame, right, you can stretch floor-to-ceiling heights, you can stretch parapet heights or shrink them, and get a very, very variable building using the same methodology. We do have max limits and minimum limits, right? You can't go shorter or taller than what we could produce, put in a box, ship, foam, mill. There's lots of things that go there, but generally speaking, we've then been able to approach lots and lots of builders and really take their design, as you've seen, and translate it into our system. Right? That was the biggest sort of mindset switch. Is I think early on we said we will give you the house, and this is the exact house, and we care what color kitchen you have. I think in the spirit of Bucky, right, he was one of the first to let go of that conception where the shell is possible to do, but the inside is much harder to industrialize, right? Because doors are local and cabinets are local and flooring nobody knows how to industrialize. So we sort of adopted that, if you will. We said, all right, the system now is not an entire house. Our first project, we delivered everything, right? Flooring, light fixtures, microwaves, right? Everything. And we found out what
that sounds really good to me, actually.
Yeah.
I was about to say,
Somebody has to
Let you deal with all the little blue stickers all over the wall.
Somebody has to lose this one. Kevin ended up living for 4 months on the finishes of a project, right? Because we're missing a single thing. It's your problem.
Yeah.
Try to be a technology innovator when you're dealing with all of that.
So that was sort of a good learning. It was a good start. We did some projects of that style, right? But it was a good start. But it was a good learning also that we can't be everything everywhere, right? Specifically when we go to different geographies, we don't have a better vendor than you for doors, right? There's no point. We bring that in. We bring in the inefficiency with it, and we split. It's a tough cookie to crack. So we said, okay, where do we deliver the most sort of innovation or actual thing, which is our panel, and what are the pieces that have to go with the panel that are years that you could actually make this thing work, right? So in this case here in this project, right, the sealants we know very well. We're bringing with us the sealants, the hardware, the attachments, the panel, the steel frame, all of the oddities that go with it. They're going to go ahead on the inside and say, all right, the doorknob is whatever doorknob you choose, right? We're disassociated for that. So we became more of like a super vendor of a very unique system for projects. Now that also has to do with engineering and a lot of the architecture and the elevations, right? So it's a little more involved in the design.
It was easy to work with you guys though on this. I think the system, I said Terry, I've
Thank
mentioned
you.
already, it was, and some of the detailing was a little different for us. We rarely reference bottom of beam, and these guys built the bottom of beam. We always use top of steel as bearing, for example. So there was a little adjustments on our end too, but it was easy.
We're worried about fitting, right?
Yeah.
Our body fits bottom of beam, top of the
I
slab.
spent a month wondering, why are they talking about the bottom of the beams? No one cares. And then I was like,
Yeah, that's our number, right? Our number literally is.
I think they're gonna do another 2x4 in the front of their wall.
So I'm actually that's kind of where I'm headed, right? And but yes, right is the short answer. So
I mean, for us, what makes sense is, we'll take a 1,600 square foot, 3-bedroom, 2-bath house. We're putting decking on day 3.
yeah,
We got the interior walls, got exterior walls. We're throwing plumbers in there on day 4.
I do think we would be fairly close. This comes up in a day as the structure, and then the panels are your stucco, if you will. So
Yeah, you pick out.
I think it's-
basically 6 plans. The repetitive nature of all this is where the benefit comes in. Where once our trade base can transfer over to work within your structure, that's where it makes sense to me. Is like when
yeah, like a
electricians
roof,
come in,
like
it's
roofing,
like-
for example. You'll bring
Exactly.
your so like.
So
And I've played in commercial a little bit in California a couple of years ago, and I like steel frames a lot, right? Their capability to weight to whatever ratio, but we appreciate that in the residential world, their people are a little sensitive to them, right? They're also manufacturing one is tough. Manufacturing 100 is not so tough, right?
well,
Because
though trying to find labor to do 2,000 units in one small market is difficult to do. It's hard enough to find wood frame labor to do that. So
Yeah.
we're talking about converting guys over to do steel and now doing wood, which is heck.
yeah, I agree. We brought a team from Georgia at the time to do the direction for us.
Yeah.
Long story. California, I can tell.
Yeah.
And all that. So, but yeah, so then we sort of went on the second version, which is what you're seeing here. Now the main difference is really variability of the type of building that you could do with it. Because the panel takes a very long time to develop, we have to use sort of the same rules of the road, the same type of panel, but we've spun it up to do lots of different buildings, right? And that's what you're seeing here. Currently, when we design a building today, this has been designed several months ago, right? We need to go through the CDs and a permit and so on. When we design today, we're using the next version of it. It's the third version, but we call it MTS2. We'll leave aside why it's 2. It's because this one
Now we
uses...
gotta stop. No.
Okay, it's because this one
back
uses...
and bring us the new one.
It's because this one uses the same panel. The old one, we treated it as a half step, and we called it 1.5, and then we went on 2. But either way, what 2 actually does is it takes the same methodology of sort of the steel superstructure. By the way, technically it could be a concrete superstructure or mass timber superstructure, but mass timber is a little bit unknown and costly in and of itself, and concrete has accuracy problems. But it can in theory work. In the Middle East, we have concrete plants, just kind of FYI. So, and what it does is it takes the same panel and it makes it a double-sided panel. So the inside is sheathed, the outside is your printing. The sheathing is a magnesium oxide cement board, so it gives us 1 hour fire rating out the box. It gives you the ability to hang pretty substantial thing. We buy a custom thickness, so it's thicker than the regular one.
On the inside that you mount it to, or does it go straight on the panel?
So go straight on the panel, you would know where you have, so the infill pattern now, because we have a sheet in the middle, we're trying to save cost. The infill pattern turns into a zigzag, and those essentially act as studs. So you would know where they are. You could find them with a volume detector, right? Not the one that detects current, but one that detects actual volume behind it. So that one now is higher level of completion. Right, you still have open areas where your braces are corners, but generally speaking, the flat panels are double-sided. It knows how to hide the steel structure entirely, so we thicken the panel so that the steel moves inside of it up to a certain size. So if we used it for this building, sorry, you guys, but
It's all right.
you would be closer to finished upon install, and we're a novelty technology. We're still not the cheapest option out there for a big builder. It is substantially cheaper than this version.
What's their R value of the panel as it sits?
So this one is going to be at the 6 and 7/8. It's let's just call it 70 pounds, so 18.4. The other one is 9 inches overall. We expect to get 23 to 25. So we're going to know when we finish testing and developing. So currently, you know, we sort of, again, like a tech company, when we have enough confidence, we've made it on small scale, we're moving production into it, we're testing and certifying it, we're starting to design with it. So that's what you're seeing, right? When you see today a designer, any customer that walks through the door, he's going to get one version ahead of this. The next version, right, specifically, and I'm going to tread lightly, this panel clearly has structural properties that aren't being utilized, right? Because there's certain things that you could or can't do. There's also a thing that has to do with elasticity, where you can't shear an element that has no give. So there's all kinds of interesting things there, but generally speaking, the version after that is the same double-sided panel. Again, we're gonna try always cut cost and cut carbon emissions, which are kind of twins. But mainly for a certain size of structure, will be fully structural, doesn't need the stem frame. We're basically getting closer to being the full SIP in that way, right? So I think always when you go tall enough or big enough openings or long enough cantilevers, you're going to introduce a frame into the building. Right? There's no, you know, even big garage doors have strong walls on two sides, right? And such, for sure in California. But for simpler structures, lower seismic, and for most of the building, we would be able to avoid the structure altogether. And that's the version, you know, if you see a version that we're designing with, it means somebody in the background is working on a version that you don't see. I'm only saying it because we already see it.
Right.
So I think part of like, running with mighty buildings in some ways is the understanding that we're forward thinking, but also forward moving. We have a lot of money invested in bringing something that will actually hit a bunch of market targets, right? We're big enough to meet true volume, and true volume means, unfortunately, actual efficiency. Right? That's just kind of what comes with it. So we do think that the next version, which is what you're designing with, is competitive. For sure in high-cost labor markets, right? Because you're getting a double-sided, you're at mud and tape on the inside, you have chases. So anywhere, I think, Texas, Florida, California, where labor is very high, we're mostly alleviating time, and time is money, and the famous equation. On the version after that, we believe we're competitive everywhere with everything. And I really mean everywhere with everything, for sure on single-family, like one-story, two-story residential. Over that, you would start having an interesting question of how do you carry that size or that height, because there's a cost with the structural panel, right? You make it structural, comes with certain things, and you sort of lose the ability to use that. So just kind of, I think, it's always nice to see one of these.
He's modest. Well, what he's describing, these guys have already built a full prototype of it, and the cost is showing that it's even considerably cheaper than stick frame construction.
From an aesthetic standpoint, how far can you cantilever it?
It's significant.
What do you mean?
Cantilever.
It's significant.